4. Balance the equations below, assuming they occur in an acidic solution. Okay, so in this case, we have hydrogen peroxide, so H2O2 plus Sn2 plus yields water, H2O plus Sn4 plus. Now, we have to balance this in an acidic solution. Whenever they tell you that you're balancing in either in an acid or in a base, so in an acidic solution or a basic solution, there are rules, and there are 8 of them. So whenever you see that they want you to balance in an acidic solution, we have to go by the rules. But the good thing is that if you follow these rules every single time in this order, you will get the answer correct. But, the challenging thing is to just memorize the steps. But I guarantee with practice, you will get these. And that's what this channel is all about. Tons of practice. We almost have 5,000 videos. So yeah, let's get to practicing. So whenever we need to balance an acidic solution, the first step is always to break that reaction into 2 half reactions. Now, how do we find out what the half reactions are? Well, you just pick the elements that go together. So, for example, I see that I have an Sn over here, and I have an Sn over here. So these would go together. And then on the other side, right, I have H's and O's in this compound, and I have H and an O on this compound. So these go together. It's as simple as that for the first step. So now I'm just going to write those into 2 half reactions. So I have H2O, 2, yields H2O. And then on the bottom, I have Sn2 plus yields Sn4 plus. And now let's just make this a little centered and give myself some room, because number 1 is already done. 7 more steps to go. The second thing is you want to balance all your elements. So I'll highlight that. Balance all the elements except hydrogen and oxygen. Don't look at hydrogen and oxygen in this step. So for example, for the first equation, you only have hydrogens and oxygens. So in this case, we're going to just skip that step for this balanced, for this half reaction. I'm just going to look down here. But these are balanced. I have 1 Sn and I have 1 Sn. So this step is basically like skipped over. And some steps are going to be skipped over. So that's totally fine. And notice how, as I'm moving through, I do the same step for both equations. Don't run through, 1 through 8 for just this one and then come back. Do all step 2, for both equations, then do step 3, then do step 4. It's just going to make it much easier. Now we're on step number 3. So in this case, now we go back to the oxygen. Oxygen before hydrogen. We always balance the oxygen by adding H2O. And the thing here is that if you need 1 oxygen, you're always going to add 1 H2O because there's only 1 oxygen in H2O. But like if you need 2 oxygens, you're going to add 2 H2Os. If you need 3 oxygens, you need 3 H2Os. So let's see, let's go to the top. And it seems like I have 2 oxygens on this side, but on the product side, I only have 1. So I need to balance it. Seems like I need to add 1 more oxygen here, and I can only add it in the term of H2O. So in general, you would say, hey, okay, I have H2O plus H2O. 1 oxygen plus 1 oxygen is a total of 2. But in this case, it's special because this compound was already H2O. So H2O plus another H2O, I could just simplify this by saying that I have 2 H2Os. There's no oxygen on the bottom equation, so I don't have to do that step for this one. So I'm done with number 3 and I'm moving on. The 4th step is to now balance the hydrogen. Balance the hydrogen by adding H+. So if you need 1 hydrogen, you will need 1 H+. So the same exact idea here. If you need 2 hydrogens, you need 2 H+. Let's see where we're at. On this side, I have 2 hydrogens. On this side, I have 4 hydrogens, right? 2 times 2 is 4. So I have 4 hydrogens here. I have 2 hydrogens here. Seems like I need 2 more on this side. So I'm going to say plus 2. H plus. Don't forget to add that plus sign. Makes everything different. I come down to the second one. I don't see any hydrogen. No hydrogen on the left. No hydrogen on the right. So that one skipped. And now we're halfway through. 5 through 8. Let's go. Step number 5 is now, since all the elements are balanced, we now talk about electrons. And we're going to add electrons, which is the E minus, always to the more positive side. So what I like to do here, I'm just going to give myself a little bit more room, is I like to split these down the middle. Because what we're going to do is we're going to see what the total charge is of the left side and compare it to that of the right side. And it's easy because you don't have to find out every individual element. All we're looking for is charges in the upper right-hand corner. And seems like I see a charge in the upper right-hand corner for the hydrogen. That's why you got to add that plus sign. I see no charge in the upper right-hand corner for H2O2, and I see no charge in the upper right-hand corner for H2O. For the ones that you don't see, they're automatically 0 charges. Now let's see what the total charge is. There was a plus for the H. That means that there was a plus 1, right? But I have 2 of them. So 2 times a plus 1 is an overall of a plus 2. Maybe I'll do 2 times plus 1 is an overall of a plus 2. And in this case, this is a 0 charge, right? Anything times 0 is 0. And now you just add them together. So 2 plus 0, your overall charge is going to be a plus 2. Let's do the same thing for the other side. Overall charge was 0. I had 2 of them. Well, 2 times 0 is just 0. I don't have to add anything here, so that's the total charge. And now we add the electrons to the more positive side. You say to yourself, okay, plus 2 versus 0. What side is more positive? It's this side. So I know that I'm going to have to add electrons on this side, but just how many? Well, think of it as a number line. How many jumps does it get to go from plus 2 to 0? You need 2 jumps. So I need 2 electrons. Do the same thing for the bottom. I see a charge in the upper right-hand corner for the Sn, and I see a charge in the upper right-hand corner for the Sn over here. There was 1 of each, right? So these are just going to be the charges. So I have an overall charge of a plus 2 and an overall charge of a plus 4. This side now is the more, positive over the plus 2. So I know that I'm going to have to add electrons on this side. But how many? Well, think of that number line again. From a 4 to a 2, I need 2 jumps. So 2 E minus. And now number 5 is done. Now, once you reach number 5 is a special step because once you do this step, you could automatically determine who is the oxidant and who is the reductant. So the oxidant, just know that the oxidant and the reducing agent mean the same exact thing. So whether, on a test or quiz, they're asking you, what the oxidant is versus what the reducing agent is, it's all the same thing. It's the one that is losing electrons. It's the one that's going under oxidation. You could think of this as Leo the lion says grr. Their oxidant is the one that's undergoing oxidation. That's always losing electrons. And that's the one that always has the electrons on the right side. Vice versa, your reductant, aka your oxidizing agent, always has the electrons on the left side because that's reduction. Reduction's always gaining electrons. So, since I have my electrons on the right side here, that follows with this, with your electrons being on the right side. So whoever you started with, that's your oxidant. So Sn2 plus, we can just say over here that Sn2 plus, and you always say the one that you started with. Your products are never going to be your oxidant or reductant, your reducing agent or your oxidizing agent. It's always your starting guys. So you only have two choices here. So Sn2 plus is your oxidant, because that equation showed those electrons on the right side, and then your H2O2, because that was the starting, right, from your original equation. The electrons were on the left side. That flows with your reductant. So H2O2 is the reductant. Okay, so let's just box that off because that's important to know. Sometimes teachers or professors will ask those questions. So it's good we went over that. Now we can continue with step 6. Step 6 says now, since we got those electrons, we have to just balance them, meaning that the electrons have to be the same number. And this is also a good check because your electrons should always be on opposite sides, right? Because one has to be reducing, the other one has to be, oxidizing. So if you have two electrons showing on the same side of the equation, go back. You did something incorrect. But now I see that I have two electrons and I have two electrons. The number is balanced. It's exactly the same. So I could just skip step 6. They're already balanced. Now for step 7, we're getting down to it. Now we want to cancel like substances on opposite sides out. Basically what we're doing is we're simplifying here. So that's why you have to have the electrons being the same, because the electrons always are going to get canceled out. In a general equation, we never see those electrons, right? When we learned balancing, we never had electrons in a balanced equation. They're there, but they're just hidden because they're canceled. Anything else that I see that's the same on both sides, I don't see anything. So that's done. And now for the last step, you rewrite as one equation. So when I take these together and I add them together, that just means that all of your left stuff stays on the left. All of your right stuff stays on your right. Doesn't matter who you start with. I guess I'll start with top to bottom, right? So we have 2H plus H2O2 plus the Sn2 plus now. And that yields 2H2O plus Sn4 plus. And that, everybody, is the final answer. And you're done. Once you do step 8, that's over. It's over and done with. And we can check that off, and this answer is done. So there's your final balance equation in the acidic solution. I really hope this helped. Thank you so much for viewing the video, and just make sure that you get down this idea of reducing and oxidation. But with more practice, I have no doubt that you guys will be able to get it. So just keep studying and keep with the videos, right? We do tons and tons and tons of problems so that on the test and quiz, you probably will see the same types of questions. So thank you so much for viewing the video, and I hope to be talking to you soon in the next lesson. Have an awesome day. Bye-bye.